Welcome friends, my name is Sagar Deshmukh. Yesterday we have completed numerical on design of combined rectangular footing. We have discussed how to design the combined rectangular footing. We have followed all the standard steps which are required for the design. Today we'll revise what steps we have followed in the design of combined rectangular footing. Later on, we'll try to discuss the changes which are there in trapezoidal combined footing than the rectangular combined footing. We'll see what care should be taken or what is the difference between the design of rectangular combined footing and trapezoidal combined footing, how to analyze or how to know by which method the footing should be designed, or on what basis the decision of providing trapezoidal or rectangular footing is taken. So first of all, we'll revise what steps we have followed in the design of combined rectangular footing. We know that in the first step we have to write all the given data of the problem statement. After that, we have calculated the total load due to two columns. Okay, so after calculating this total load includes load on column plus self weight of footing. Okay, self weight of footing is assumed as 10% of load on column. Okay, after calculating this, we have calculated the area of footing required for this total load. For calculating this area of footing, we have used formula as the area of footing equal to the total load divided by SBC of soil bearing capacity. Okay, so after calculating this area of footing, we have calculated the length and width of footing. If any restriction is given for width of footing, we have to or length of footing, we have to take that in consideration while calculating the length of footing. Here, while calculating this length and width, we have to take care that the center of footing, that is center of area of footing, should match with the resultant or the position of resultant of column load. Okay, so this care should have to be taken while calculating the length and width. After this, we have calculated the net upward pressure. Soil pressure. Okay, after calculating this, we have calculated the trial depth, for calculation of this trial depth we require the bending moment calculations. Okay, so we have calculated the bending moment in footing at various positions where we might get the maximum bending moment. Okay, so we have calculated bending moment at 2 or 3 sections, and we have taken maximum calculated bending moment for equating with the balancing moment or limiting moment. We have equated this two, okay, and we have calculated the trial depth. After calculating trial depth, what we have done, we have taken the checks, various checks for one way and two way shear, okay. One way and two way shear, okay. In that, we know that the check for one way shear is taken at a distance of D from face of column. So for one way shear, the critical section is at distance of D from face of column, whereas for two way shear, the critical section is at D by 2 from face of column. This two way shear is also called as punching shear. So we have to take the check for the shear if the resisting power or resisting shear in the footing is equal to the shear stress coming due to external loading, then there is no need to provide any extra reinforcement for shear. If this shear stress due to external loading exceeds the resisting power of concrete, then in this case we have to provide some extra shear reinforcement for excess shear stress, okay. So this care has to be taken in this. After calculating, after taking these checks, we move towards next step, which will be of calculating the steel for at various sections. So according to the bending moment which we have calculated, we go for providing different reinforcement as per the BM at that point or position. So this AST is calculated for different bending moments. In previous problem, we have calculated bending moment under column A, column B, and for the maximum hogging moment in between column A and B. So these three moments which we have calculated are taken for calculating three different area of steel at different positions. Or okay, after calculating these ASTs, we equate this all the AST or area of steel with AST minimum at any section. Area of minimum steel at any section should be 0.12 divided by 100 into B into capital D. This is overall depth, this is width, and this ratio is for torr steel. Okay. If torr steel is there, then minimum area of steel at any section in the footing should be 0.12 upon 100 into BD. If any of the AST, where any of the value of AST comes less than this value, then we'll provide AST minimum at that section. Okay. So for if we are using nowadays, it is very likely to say that we are going for torr steel. But if in any case we are using mild steel, then this formula for area of minimum steel will be 0.15 into divided by 100 into B into D. So this will be the formula for mild steel, minimum reinforcement at any section for mild steel. So this formula is used in place of this if mild steel is used. For torr steel, this formula is used. Okay, so like this we are calculating the main steel at any section. Okay, after calculating this area of steel, what we have did, we have moved towards the next calculation, that was about calculating the spacing for all the reinforcement. Okay, so one also can calculate these spacings with simultaneously when we are calculating the area of steel. So spacings are calculated for main and distribution steel as per IS 456. Okay, after calculating these spacings, the last step is to provide or sketch out the reinforcement detailing. So these are the steps which we have followed during the design of rectangular footing, rectangular combined footing. Okay, now let's see when and how we'll decide which footing should we provide, as we are having two types of combined footing, that is rectangular and trapezoidal. First condition is if the restriction of width is given in the problem statement, then we'll use rectangular footing. If restriction of length is given, then we'll go for trapezoidal footing. Okay, then second point, if equal loading on column is given, then we'll go for rectangular footing, rectangular combined footing. And if the major difference is given between two loads of column, then we should design it according to the trapezoidal footing. So these are the main criteria on which we may decide which footing should we prefer. Okay, so this is the criteria for selection of type of footing, type of combined footing under different condition. Okay, now we are moving towards the next type of footing, as we have designed rectangular footing. In the next video we'll start design of trapezoidal footing. Okay, so for trapezoidal footing, we will follow same steps as we have done in the design of rectangular footing. Few changes will be there, as we know that in the trapezoidal footing the width of footing will not be constant, so it is varying like this. The width of footing is varying. If suppose this is column 1 and this is column 2, so like this we are providing trapezoidal footing. In this condition we can see that this column must carry, or this we can guess that this column is carrying larger load, whereas this column is carrying smaller load, because of which we have provided smaller area for this footing. Okay, now we'll see how to calculate the width of footing, how to decide the width of footing, then how we are calculating the area, which moments are calculated for calculation of area of steel. So these parts are very interesting. As we have discussed in the previous videos, that for a design of any footing we are following similar procedures. There are few changes according to the types, so it is very important for us to remember all these steps. That's why I have taken this revision on the steps of design of footing. So my aim behind this is you should revise all the steps which we are following in the design of combined footing. Okay, so it will be very easy to understand the changes which are there in the trapezoidal footing once you remember all the steps of design of rectangular combined footing. Okay, so this whole design is based on IS 456. You all should refer this IS 456. Oftenly we are discussing the calculation of tau c, that is permissible shear stress, which is calculated from percentage of steel. So I expect that you refer this IS code and you see how we have calculated this value of tau c from PT. Okay, so there are some other specifications are also given, like spacings, various spacings, spacing for stirrups, spacing for main bars. So rules regarding these are given in IS 456. So I expect that you are referring the IS code and you are learning how we have calculated the various terms like tau c, spacing from the IS code. Okay, so this is about the introductory part of design of trapezoidal footing. In the next video we'll start one numerical related to trapezoidal footing. After completing this numerical, we'll once again revise what we have what steps we have followed in the design, and after that we'll move towards the next unit in the coming videos. Please comment or you can ask me if any one of you is not understanding the steps in design of rectangular combined footing. Okay, so just try to learn the basics of design in the meanwhile time. Okay, so the homework for you will be to find out, as I'm taking this video online, is very difficult to understand whether you are concentrating or studying on the same videos or not. But to check whether you are listening this video or not, I'm giving this homework. Please comment me in the comment section how much cover should be provided for beams, minimum cover for beams, columns, footings and slabs. Okay, so you have to write in this sequence. Just comment how much cover we should provide, minimum cover we should provide for beams, columns, footing and slab. Okay, so this will be for your homework. Let's meet in the next video with design of trapezoidal footing. Thank you for watching this video. We'll continue with design of trapezoidal footing in next video.